Hello everyone, we're going to start off today. We're going to be talking about area of triangles, but before we do that, let's do a little review. So first of all, I would like you to solve a right triangle. So first thing I would recommend that we do is let's draw a right triangle on our paper. Okay, so you need to designate one of the angles as being about 32 degrees. It does not matter which one you pick. I'm going to pick this one because it looks a little smaller. Again, it does not matter. And so that would make this angle A. And of course, when you're doing right triangles, the right angle has to be C for the Pythagorean theorem to work. So as I look at this problem, let's go ahead and let's put this 10 on here. That's what I have right now. I can't do the Pythagorean theorem. So one thing I'm going to do is I'm just going to do some trigonometry. So first thing I'm going to do is I'm going to find the side that's over here, that one that's AC. So I'm going to do that with some trigonometry. So you want to imagine that you are here in this picture and the side that is opposite is over here and adjacent is over there. So if you think about SOHCAHTOA, that would lead us naturally to tangent. So I'm going to have tangent of 32 degrees equals opposite, which I do not know. I'm just going to call it AC over 10. Now, if you're using one of my calculators, or perhaps you haven't been in your calculator in a while, let's just make sure that our mode is set up correctly, because if we have the wrong mode, we will exactly have wrong answers. And as you can see, mine is not right. So I'm going to switch it over to degrees and go back to my home screen. Okay, so I'm going to solve this problem algebraically, and then I'm going to put it in the calculator. So I'm going to move this 10 to the other side by multiplication. And then when I put this in my calculator, it's going to tell me the length of AC. Fantastic. Okay, so 10, tangent button, 32, close parentheses, press enter. Looks like it's about 6.2. Now, I'm going to use the triangle sum theorem to find angle A. So triangle sum simply says there's 180 degrees in a triangle. So 180 minus 90 minus 32 tells me the other angle is 58 degrees. Okay, so now I got to make a choice. To find AB, I can do the Pythagorean theorem because this is a right triangle, or I could do another trig ratio. I'm just going to do another trig ratio. Again, totally up to me. Since this is adjacent and that's hypotenuse, I'm going to select cosine. So cosine of 32 degrees. Again, you have a lot of options on this. Is your adjacent side over your hypotenuse of AB. Let's multiply the AB to the other side just like we did the 10 on the last problem. So unlike our last problem, our variable is not isolated, so we do need to divide the cosine of 32 to the other side. And at this point, I'm going to pick up my calculator and get an approximation. Now, while I'm doing this, I do want to mention to you that if you chose to do the Pythagorean theorem, you should get an answer that's very close, but it could be off by up to a 1/10. But that's okay, all right? Being off by up to a 1/10 is perfectly fine with numbers this size. So that's solving a right triangle. Just a little quick review in case you'd forgotten how to do it. Hopefully you don't have any questions. So let's talk basic area. So you have seen these formulas before. For part 1, you have seen it before. So area of a triangle, just to remind you, is 1/2 base times height. And just remember that height is always perpendicular to the base. Now, I've given you this height of 10, basically your altitude, which means it's perpendicular. So your area in this case is 1/2 17 times 10. Okay. So 0.5 times 17 times 10. And that gives us 85 square units. In this case, it would be inches because area is always squared. Okay. Again, I have given you the height, which is perpendicular to the base. So that's area equals 1/2. And your base on this is 2, and your height is 9. Okay, you're going to put that in your calculator. You will get 9 kilometers squared. Okay, so hopefully all of that's super familiar to you. Now, you may have seen Heron's formula before. Heron's formula is specifically used when you do not know the height of your problem and it's not something that's easily able to be accomplished. So like in this case, I don't know what percentage of the 10 units are at the bottom are on each side of this, and I really can't guess particularly well. So I can't find this little piece really here that I'm going to switch over to the word height. Like, I can't find it real easily. All I know are my 3 sides. So this is where Heron's formula is useful. Now the S on each one of these, that stands for this value down here. Please notice it's divided by 2, not 3, so it's not an average, it's S. A, B, and C represent the 3 sides. So here's how this looks in the problem. So first thing you're going to do is you have to find S. So S is the sum of the 3 sides divided by 2. So let's go take our calculator and let's do that. So I have 9 plus 17 plus 10 divided by 2, and that gives me 18 as my value for S. Now, this is a really funky little area formula, but again, not a hard formula. So you're going to write a big, long square root. Under your square root, you're going to have S. Then you're going to take the sides one by one, and it doesn't matter which one you start with, but you're going to do S minus each one of them. Now, if you do this in the wrong order, you'll end up with a negative area, which isn't right, of course. So we just need to make sure we get our order right. Should you get a negative area, it just means you accidentally got those in the wrong order. Okay, so I have my formula all filled in, and now I'm going to reach for my calculator. So square root 18, open parenthesis, 18 minus 9, close parentheses, 18 minus 17, and of course 18 minus 10. And that tells me that my area in this case is 36 units, because I don't know what it is, squared. And that's all there is to Heron's formula. Let's try one more Heron's formula. So again, I've got a triangle with side lengths of 6, 4, and 8. Sorry, I said those in the wrong order. Let's find S first. So that's 4 plus 6 plus 8 divided by 2. Again, let's verify everything with our calculator. So 4 plus 6 plus 8 divided by 2, and I get 9. Now I'm just going to plug it into my formula. So you always write the 9 first, because that's S. That's right there in the formula. Then you do 9 minus each of the sides. And then you're just going to reach for your calculator and type it in. So I end up with 11.6 meters squared. Okay, so the stuff that we've seen so far should be familiar to you. But, you know, if it's not, it's okay, because we just reviewed them. Let's talk about our totally new stuff today. So we've talked about law of sines. This is a formula which uses sines to find an area of a triangle. Now there are 3 formulas in our problem, in our options, so let's take a look at them. So you're going to do 1/2 a times b times sine of c, or, and this thing right here, that stands for area. It does not stand for angle A. That's area. Could have been more clear when I wrote that. 1/2 b times c times sine of A. And then our last one of these areas is 1/2 a times c times sine of B. Now before you start saying, oh my God, I got to memorize 3 formulas, it's literally 2 sides and the angle that you're not using. So notice it's side A and B, so then you use angle C. Side B and C, then you use angle A and C, so you use angle B. Okay, so let's take a look at our problem. So right now, what we have is a bit of a problem. We can't use SOHCAHTOA on it. It's not a right triangle. And it wouldn't be easy for us to drop an altitude into the problem either, because let's say that we did, which we really don't want to here. What percentage of the 21.2 is on either side? It looks like it's in the middle, but maybe it's not. Maybe this triangle's not drawn to scale. So since we don't have any of that information, we can't use that altitude. So instead, we're going to use law of sines. Okay, so I'm going to put an A, a B, and a C on my problem, which means that this is C and this is little b. So looking over at the formulas, the only formula that has angle A is this one with those 2 sides. So we're just going to plug it in. So my area is 1/2 21.2 times 16.5 times the sine of 25 degrees. And all you have to do is type it in your calculator and you, well, get the area. It's like a really clean little nice formula. So 0.5 times 21.2 times 16.5 times the sine of 25 degrees. Done. And so my area quite simply is 73.9. And I don't see any units on this, so I'm just going to put units squared because area is always that. Yes, it's that simple. That's all you have to do to work this problem. Let's slide down. Let's do one more together. All right, so this time we have angle C, which means that this must be side B and this must be side A. And if you look up above in the box, there's only one option that'll work with that, which was the very first one. Let's plug it in. So I'm going to have 1/2, and you're going to take your 2 sides that are given, multiply it, and then times sine of whatever your angle is, 94 degrees, and that's going to give you your area. Okay, so 0.5 times 12 times 18 times the sine of 94. Ta-da! My area is all finished. It's 107.7. And I don't have any units on this one, so I'll just say it's units squared. So that's literally what you've got to do today. So just a quick recap before I leave you. We have the basic area formula where you happen to know the height. You do not know the third side on either of these, but you have a height. Then we have Heron's formula. This is specifically used for when you know 3 sides and that's all you know. You don't have any angles. Yeah, I know that's a right angle, but that's not the angle I'm talking about. I'm talking about that one, or that one. So you don't know any angles. And then this one is used whenever you have a situation that is side angle side. Now, what are you supposed to do if you don't have one of those? Something else. But these are the 3 formulas you are responsible for in this unit. Your homework should be attached to the very next page. Please find the area for all of those triangles. Use the appropriate formulas for it. Okay? And I will see everyone back here. I will see everyone back in class tomorrow. And I hope you have a really good day.